Let's now take a look at a geometric series. Just like with a sequence, it's a set of numbers. In this case, they're added instead of just listed, where you can find a common ratio. So take any one of the numbers, divided by the previous number, and you'll get the same number or the same ratio. For example, if I take 256 and divided by the previous number 64, I get 4. If I take the number 1024 and divided by the previous number 256, I get 4. So you can see that if you take any number divided by the previous number, you get the same ratio, the same common ratio. You can also find the nth number just like with a sequence using this equation. Let's say I want to find the fifth number in the sequence that is equal to the first number in the sequence, which is 1, times the common ratio 4, times n minus 1 would be 5 minus 1. So this would be equal to 4 to the fourth power, which is equal to, let's see, 64, 256. And the fifth number, 1, 2, 3, 4, 5. Fifth number, 256. That's exactly what I found. But you can also find the sum of the first n numbers in the series. For example, what if I want to find the first 6 numbers, the sum of the first 6 numbers in the series? So let n equal 6. Then using this equation, the sum of the first 6 is equal to the first one, a sub 1, which is 1, multiplied times the common ratio, which is 4, raised to the n power, n was 6, minus the first one, which is 1, all divided by the ratio minus 1, that would be 4 minus 1, or 3. All right, so this becomes 4 to the 6th power minus 1. For that I will need, so 4 square, let's see, 4 e to the 6th equals, that's 4,096. So this would be equal to 4,096 minus 1 divided by 4 minus 1, which is 3, which is equal to 4,095 divided by 3. So minus 1 equals, divided by 3 equals, and we get 1,365. So that would be the sum of the first 6 terms, 1, 2, 3, 4, 5, 6. All right, what if we wanted to find the sum of the third term through the 7th term? So the sum of 3 to 7. Well, to do that, that is equal to the sum of the first 7 minus the sum of the first 3. So if we're going to do that, let's find the sum of the first 7. So that would be the sum of the first 7 is equal to, using this equation, we get the first one times the common ratio 4 raised to the 7th power minus the first one, 1, all divided by the common ratio minus 1, which is 3 minus 1. And we subtract from that minus s sub 3. So it would be, how about if I write it like this? That might be a little bit better. So s7 minus s3. So I'm going to subtract from that s3, which is the first one, times the common ratio 4 to the 3rd power minus 1 divided by the common ratio minus 1. Okay, what's 4 to the 7th power? So 4 to the 7th power, that is equal to 16,384. So that's equal to 16,384 minus 1 divided by, this should be 4 minus 1, that is 3, minus, that would be 1664 minus 1 over 3. So this is equal to 16,383 divided by 3 minus 63 divided by 3. And so subtract 1 from that, divided by 3, equals, that would be 5,461 minus, would be 21. So this is equal to 5,440. So sometimes they'll ask you to find the sum of 7 minus the sum of 3. In other words, the sum from the 4th one on to the 7th one, and that's how you do that. Okay, so hopefully this will help you work with geometric series, and then we have one more example that will be on the next video.